Dear friends, in this video, we will look at some examples as to how to formulate the hypothesis in a statistical problem. All of us know that formulation of the hypothesis is the key to decision making. Let's look at 4 examples. Example 1, hypothesis formulation. Is the average waiting time for the customers of Smart Supermarket at the checkouts greater than 15 minutes? This is the question, problem question framed, or this is the problem, and we define the null and the alternative hypothesis. Remember, the hypothesis is a statement about the population parameter. In this case, it happens to be the population mean. So we must keep in mind that we are trying to infer about the population based on sample, of course. Let's say mu equal to population mean. The null hypothesis is denoted by H naught. Mu is equal to 15. It is status quo. Mu is equal to 15. The alternative hypothesis, HA, is mu greater than 15. So it's called a directional hypothesis. In this case, we want to find out whether it is greater than 15 minutes. So we want to prove, for example, somebody wants to control the waiting time customers spend in the checkout counters. They have to find out whether it exceeds 15 minutes. And therefore, the null hypothesis is the status quo. Mu is equal to 15 minutes. Alternative HA is mu greater than 15 minutes. H naught is null. HA is alternative. And the alternative hypothesis has the direction. It's called the right tail test. It is right to the mean. So it's one tail test, which is the right tail test, mu greater than 15. Let's move to the example 2. Is the proportion of households owning color TVs in Chennai less than 0.4? In other words, we want to find out whether it is less than 40%, the proportion of households owning color TVs. As before, we represent capital P is equal to population proportion of households owning color TV. Null hypothesis, status quo, H naught, P equal to 0.4. The alternative, we are testing less than 0.4. So HA, P less than 0.4. This is also a directional hypothesis, one tail test, which is the left tail test, which is left of the mean. And that mean proportion, you mean, P is equal to 0.4. So we will apply some test later, we will see. But primarily now we are looking at the formulation part. The null hypothesis is the status quo. If you have evidence, you can prove the alternative, HA, P less than 0.4. Now let's look at example 3. Is the average expenditure per household on eating out significantly higher in Bangalore than in Calcutta? The first 2 examples are depending upon a single population, univariate. Here we have to compare population behavior of Bangalore and Calcutta. So if we represent mu B is equal to population mean expenditure in Bangalore, amount mean expenditure spent on eating out. Mu C is the population mean expenditure spent on food in Calcutta. Eating outside. So population mean expenditure eating outside in Bangalore is represented as mu B. Population mean expenditure in Calcutta, that is spending in eating out, is mu C. Null hypothesis H naught, status quo mu B is equal to mu C. There is no difference. Alternative hypothesis, Bangalore is higher than Calcutta, mu B greater than mu C. This is example 3. This is called the bivariate analysis. The first one is the univariate. Here we are comparing two populations. So there are two parameters, mu B and mu C, representing Bangalore and Calcutta. Let's look at example 4. Interesting example on the opinion poll, you may say. So, two random sample surveys conducted with 2 months gap between the two assessed public opinions on the outcome. The question that was posed was, if the general election was going to take place tomorrow, would you cast your vote for or against the ruling party? If the general election was going to take place tomorrow, assume that, would you cast your vote for or against the ruling party? So let us represent symbolically PR1 equal to population proportion voting for ruling party in survey 1. That is the first survey. Then PR2 is equal to population proportion voting for ruling party in survey 2, which is conducted after 2 months. Now the null hypothesis H naught is PR1 is equal to PR2. Status quo, no difference at all between the behavior in the first survey and the second survey. Alternative hypothesis, no, they are not same. So PR1 not equal to PR2. Now this example, the alternative does not have a direction. It is not equal. Once the null is rejected, the alternative says, I do not know PR1 is greater than PR2 or PR1 is less than PR2. This is called the two-tail test. This test is called two-tail test, and the non-directional hypothesis two-tail test. Oftentimes, we may have to deal with the one-tail test in marketing and other examples, but it all depends on the problem. Whether the opinion has changed or not, we are testing, and therefore this is an example of a two-tail test. Thank you very much. I hope you have gained some knowledge. We will see you soon in the next video. Thanks a lot once again.